Good morning and happy Monday to you. Today what we are going to be doing is we're going to work on solving complex linear equations. Now, complex linear equations are really not any different than what we've been doing before. What we're still going to be doing is trying to combine x's and then solve for x. So the process is going to be pretty much the same. The only thing is, once you get into complex linear equations, what you are changing is you are going to be just doing a lot more steps. Now, that means when you're going through your work for these, you need to be so careful because every problem will take longer to solve because there's more steps to take. And remember, every step, something can go wrong if you're not careful. So if you're really careful, these won't be harder than any of the ones that we've done before. However, if you hurry, these are going to be very hard and you'll end up redoing them 3 or 4 times. So take your time, watch your negatives, and record every step. Let's try a few out so you can see the process. Now remember, my goal in solving is to try to get an x equal to a single number. And I know I can do that provided I only have x's and I have an equal sign that tells me, hey, I'm going to be able to most likely balance this out. So what I'm going to start with is I'm going to look at both sides. Because this one is such a mess, like look at how much stuff is on this side and how much stuff is on this side, I'm going to try to simplify each side of the equation, kind of ignoring the other one before I go about solving so that this problem is easier to work with. Now remember, when you are simplifying, you need to be very careful that you are following the order of operations. And that is, of course, our GEMDAS, where we start with grouping, we look at exponents, which we don't have here. We then do multiplication and division, addition and subtraction last. So that's the order that I'm going to be following as I go about simplifying one set at a time. So let's start with this side. Remember that the first thing that we need to do is we need to get rid of those grouping symbols. Since I can't combine the 1 and the negative x, that means that I'm going to have to distribute this 4 and multiply by both of the things in there. Notice we have a negative, and if we have a negative, you've got to watch it very carefully so it doesn't go missing. That negative is attached to the x. So 4 times 1 is going to give me 4. 4 times that negative x gives me a negative 4x. And I still have the plus 3 from above. Or 3x. Don't lose an x there. That would be problematic, right? We've only just begun. Now once I have this, what I can do is I can combine like terms. Again, don't forget that this negative belongs with the 4x. In fact, you can even write plus a negative 4x, so you don't forget that that is a negative 4x. So when I'm combining like terms, I'm going to look for x's, and negative 4x plus 3x is just going to give me a negative x, and in front I have that 4 plus. So now I have 2 terms that are not alike, so I can't combine anymore, and I'm done simplifying. I then move on to the other side, because while I've simplified this side, I have not simplified the other side. And this one still has parentheses which trap my x in place. So I'm going to distribute that negative 2, and again, we have a negative, so really watch that. And I'll get here a negative 2x plus, well, negative 2 times 1 is negative 2. And since I can't combine these, since this one has an x and this one does not, that means that when I drop it down to line up with the other, I'm just going to actually leave it the same. Well, now what I have is a equivalent equation where I am going to need to start moving things from side to side because I can't combine anything on a single side. And remember, as soon as you're moving things from side to side, what you are really doing is you are solving. So let's go about that solving process. The first thing that I'm going to need to do or want to do is really get all of the x's on the same side. We tend to like to move the smaller number, though in the end it won't actually matter. Since negative 2x is smaller than negative x, I'm going to start by moving that 2x to the other side. Remember that here, this is like a normal number, so instead of subtraction, I'm going to add. I'm undoing as I solve, getting rid of that addition and subtraction first. So I'm going to add 2x to both sides to keep everything balanced. And that's going to give me, on this left side, 4 plus, well, negative x plus 2x is just 1x, or we can call that x. And on the other side, I'm left with that negative 2. Don't lose your negative here. It's very important. Next, I'm going to subtract 4 from both sides. And remember, this is getting that x all by itself. That's my goal. I'm trying to move everything away from the x now that I have all the x's together. So that gives me x left on the left side. And on the right side, I have negative 2 minus 4. So think about your answer here. We're going to have a negative answer. And since both numbers are negative, what we're going to be doing is we're getting more into the negative. Like I owe $2, I owe $4 more, I now owe $6 in total is how you can think of that negative sign, as like owing it. And I now have x is equal to a number. Now, of course, you guys know that I'm not really done at this point, because now that I know what x is, my next step is always checking my answer. So I've simplified, I've solved, and now I need to check. And no, that is not using an answer key, unfortunately. What I'm going to be doing is I'm going to write out my original formula, the very first one, not the one that I modified. And I'm going to leave a blank for each of those x's because I'm going to put negative 6 into those. And really watch, put parentheses around so you can see where I have each of those x's in my original equation. I'm now just leaving a blank. So here, I'm going to end up with, that is my overall equation, put my supposed value for x in, and watch your negatives. This is going to be a negative 6, a negative 6, a negative 6. And notice I'm ignoring everything else around as I'm filling this in. Don't lose your negative just because there was one in front here. So this is going to give me something that I can check. Here I have 4 times 1 minus a negative 6. Well, this is 1 plus 6. So what I really have here is 4 times 1 plus 6, or 7. Plus, well, 3 times negative 6, I can do that. That's a negative 18. On the other side, negative 6 plus 1 is a negative 5. And 2 times negative 5 gives me negative 10. So now what I want to see is this going to give me a negative 10? Well, 4 times 7 is 28. And when I do plus a negative 18, what I'm really doing is subtracting my 18 from that side. And what I get here is 10 is equal to negative 10. Now that's not true. So that means something went wrong. So what I'm going to check first is just that I didn't mess up any negatives in my check. And remember, negatives are usually where a lot of our problems begin. So on this side, negative, like 1 minus negative 6, I know that's 7. I know that a positive times a negative is a negative number. So these are looking good. On the other side, I have a negative times a negative. Ooh, and a negative times a negative is always positive. And again, that means that each of these become a positive 10, because of course that didn't change after my first one. So I do end up with 10 is equal to 10, which is the correct answer. Now, notice with this how easy it is to lose a negative even after you did everything right in the solving. So make sure that if you have an error, check negatives. They're a simple thing to lose, and they're also a pretty simple thing to fix once you find it. And I know since my 10 is equal to 10, that means these two sides are balanced when I put negative 6 in for x. So my final answer was correct. X is equal to negative 6, and that really would be the end of this equation. Let's get one more example, and I'll go through it a little bit quicker, just in case you're struggling with the concept. Okay, let's run through a second example, and we're going to, again, with these complex ones, be starting with simplification. And we do this one side at a time using normal order of operations. On the left, I want to get rid of my parentheses, so I'm going to distribute this 1/4. So 1/4 times 12x is going to give me 3x. And 1/4 times 16 is going to give me 4. Remember here that when you're multiplying by this fraction 1/4, you're really just dividing the number by 4. And if you're doing this on your calculator, please be careful. Like if you're going to keep it as a fraction, put parentheses around it so that your calculator doesn't misread what you want it to do. So that 1/4 times the 12x would be 1/4 in parentheses times 12. On the other side, when I'm simplifying, since I'm done on this side, I can't combine those anymore, I'm going to have to watch out that I don't lose the negative that's currently in front of this 3 or the negative that's currently in front of the 2. So I have 10 plus, well, let's distribute that -3. -3 times x is just -3x. A negative times a positive is a negative. -3 times -2 will have to be positive because a negative times a negative is always positive. And 3 times 2 is 6. Now I'm going to combine my like terms on this side. I have a 10 and a 6, both of which are constants. They don't have variables. So I can add those two together to get 16. And I have that -3x still hanging out over here. At this point, I notice that I've simplified as much as I can. So I'm going to move over into solving, and I'm going to first just try to get all of my x's together by moving the smaller x value just to keep it a little bit easier on myself. So I add that 3x to both sides to cancel out this -3x. That leaves me 16 on the right side, and on the left, I'm left with 6x plus 4. Be careful here, this is not 0. You have a +3 plus 3, which is always 6. Now I can subtract 4 from both sides. Again, my goal is to move things away from the x now that I have only one x. And that is going to be giving me, well, 16 minus 4 is 12. And on the other side, I am left with 6x because my 4's have canceled out. Divide both sides by 6, and I end up with the answer x equals 2. So since x equals 2, I have a solution, and I need to check that solution. So go ahead and see if that works. Pause the video right now, do the check, and then unpause it to see the actual check and see whether or not you did it correctly. Here's what you should have gotten. 10 is equal to 10. And since 10 is equal to 10, it means you've found an instance where x is a solution. In fact, it is the only solution, and you would be done. Go ahead and try out this final one for your homework. And with this final one, I want you to show every step like I did. Of course, you don't need to color code it, but make sure that you show the simplification, the solving, and your check to confirm that your answer is correct. Tuesday, you are going to be having an assignment to do more of these. So just keep that in mind. If you find that you have questions with the one that I am assigning here, then you might want to ask them today so that tomorrow's assignment will be easy. This is the problem I want you to solve. Please note this is a 2, not a Z. Watch your negatives. Have a good night.